Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at Chem Advantage.
Well, here we have a full FRQ that involves stoichiometry and balancing reactions in moles, grams. It's a beauty. It would start off pretty simply in a AP chemistry question. They give you an iron bolt that weighs 5.21 grams. If you're doing this problem at my website, you're going to have a different mass than this, but you'll be able to follow along. Then it says, after the bolt had been standing in moist air for a month, exactly 1/8 of the iron turned into rust. Iron oxidizes pretty readily unless you've got another alloy with it that'll prevent that. Here is the final question. Calculate the final mass of the bolt. Very, very short FRQ, but they require a lot to answer. They would give the reaction here. They'd say, okay, here you've got some iron, you've got some oxygen, and we've got rust. Well, first we got to balance the reaction. We're a chemist. We're going to say what's really happening in terms of atoms. And if you look at it, you see this subscript 2 on this iron free oxide. It's got a charge of +3, the oxygen, the -2. You should understand that naming convention. And you say, okay, I've got 2 irons, so I've got to start with 2 irons. And you would just put that coefficient of 2 there and say, okay, and I have 3 oxygens, and, well, diatomic. Diatomic says in a balanced reaction very often are going to give you some problems because you can have an odd number in a compound, but as an element, they've got to be even. So the only way to balance this is to give it a 3/2. Now, in thermochemistry problems and such, very often they'll use 3/2, which would mean that you've got 2 moles of iron reacting with 3/2 of a mole of oxygen to make 1 mole of iron 2 oxide. But in balanced reactions, they like to talk about atoms and molecules. So this isn't good for them. Very often on a reaction, they'll say balance this reaction using whole numbers. Well, when you get a fraction for a diatomic substance, it's just a matter of doubling things. So you get rid of this 1/2. So you have 4 irons and you have 3 oxygens because you're going to have this doubled. You want to double this to get 6. So with this balanced reaction, we're ready to start this problem. We have an iron bolt that weighs 5.21 grams. Now, I really prefer to do this type of problem using a little table that keeps track of everything. So I would put that reaction balanced in this box that shows what's happening. Then I have a row for the amount of substance. This is going to be our moles. I'd look up the molar masses. Quite often now in AP problems, they give you the molar masses to save a little bit of time. Then here's my masses. So I've got nice, neat rows, and I can see what's happening. I didn't bother with the oxygen because I realized the oxygen is not going to be relevant for this problem because the question says calculate the final mass of the bolt. You might be tempted to quickly put 5.21 grams down here for the mass, but read the problem. That's really important. After the bolt, they give you this 5.21 grams. So you say, okay, iron bolt, you're thinking I'm going to drop that in, but here, read the problem. Exactly 1/8 of the iron turned to rust. This is critical. Only 1/8 of this bolt is going to react. So our mass isn't going to be 5.21. Our mass is going to be 1/8 of that. You're going to take that 5.21 grams and divide it by 8. Now, one of the things about grading, if you put that 5.21 and did your calculations with all 5.21s, you'd get partial credit. They say, okay, they were consistent, they found moles, they found iron oxide, and if you're consistent, you'd only lose 1 point out of this. But don't lose that point. Read the problem. Here's the 1/8 of the iron, so I'll take that 5.21 and get my calculator going. Here's my calculator. I'm going to start putting some numbers in. 5.21, and I'm going to divide it by 8. That'll be my mass of iron that I'm going to put in here. And again, it gives me far more significant digits than I really need. My answer, and I'd write that out. I'd show that. You might even just get a point for that if you show that. 6.51 grams of iron reacted. And if you're doing an FRQ, I would write this out because this sort of helps you along. Because if you just see a bunch of scrambled numbers, you can get lost very easily. So this is a hint for you. I mean, the grader will like it. If you just wrote down 0.651 grams, this really helps you more than your grader. So that's the mass I'm going to put in. I'm going to say this is what reacted, the 0.651 grams. And of course, a chemist is going to change this into moles because moles is going to make this easy. This 4321 is moles. It's not mass. Well, you should know by now. I mean, an AP chemistry student says, okay, I can use dimensional analysis for this, but I know grams divided by molar mass, in this case of iron, and again, you'd have a periodic table if they didn't give it to you. You would go to this problem is on WebAssign, so you go up and scroll to the very top of your assignment, and there you could go to the classroom, and you'd have the week's work. This is going to work in week 32, mass relationships, where we have stoichiometry in the outline, but we really need the periodic table. We'd go there and find out that iron's got the 55.85 grams per mole. So back to our problem. We're going to take that 0.65651 and divide it by the molar mass. My calculator again. Nice. My previous answer is there. I'm going to divide it by, this is the 0.651 grams. This reminds me, I've got grams. I wrote it down. That's useful. Don't hurt yourself by not writing things down. Your pencil's going to help you a lot. It's an assistant for you. It reminds you of things. And we've got our moles, and you'd put your answer down and show that. And this is our moles of iron. I would write down moles of iron. This is probably worth 1 point. Changing grams into moles on AP exam, very often that's your first point. It's a giveaway. Well, not a giveaway. No, you have to know about atomic masses and all that. It's not a giveaway, but it shows that you've gotten somewhere, and it gives you a better chance of passing the exam. And that was on my calculator. I'll put my calculator up. I didn't need all those digits, so I just put 0.0117. You can see we've got a smaller amount, and I've got it underneath my iron. And one of the nice things about a table like this, it helps you organize stuff. You say, okay, here's my 4 iron. And you know that on this table, the moles of substances follow the coefficients. If we have a 4 here and a 2 here, it's going to be half that amount. You know this mole of iron, 0.0117, is going to be half of that when it turns into iron 3 oxide. You could do that without using a calculator, but I've got the calculator here, and I'll divide that by 2. 4 to 2. You could have divided by 4 and multiplied by 2. This would be our answer, and it makes sense. It's a little bit less. So we can put that answer in as our moles of iron 3 oxide. This is how much rust that iron will turn into. And again, the table helps you with that. You see the iron turning into iron oxide, and we've got half the number of moles. If you're doing an FRQ, you show how that was done, and you'd set up your moles of iron. And now next, we're going to have to find out in terms of grams. Again, this was given to you in the problem, and that's pretty typical, but I'm sure you'd be able to find the atomic mass of this. Since we've got moles, by now you should know automatically multiply grams by moles, and that will give you your mass of iron oxide. Calculator time, sequence, I'm showing them all, and I'm going to multiply by my 159.7. There's our mass, 0.931, and again, don't put down all these numbers. Don't embarrass your chemistry teacher by using those. You know it's just going to be a 0.931, 3 significant digits grams. And look at it. Let's see if it makes sense. We're starting with some iron, and we're converting it into rust. It's gaining oxygen. It should become heavier, and it did, 0.931 grams. This is reassuring in that you see that it makes sense, because it's easy to mess up, putting a number in, dividing instead of multiplying. Even though you're using a calculator, your calculator is perfect and beautiful in terms of multiplying things out, your answers have to make sense. Check to see if they make sense, because it's easy to put a number in incorrectly. And if you put garbage in, you get garbage out. Final mass of the bowl. You say, okay, I got 0.931 grams of rust. When I've talked to graders, one of the pieces of advice that they give is a simple piece of advice. they say, have your students answer the question. You say, what? I mean, why not? Yeah, this is 0.931 grams. I'll write that down. No, read the problem. Calculate the final mass of the bolt. They didn't ask for the amount of rust that was produced. They wanted the mass of the bolt. And the mass of the bolt is in 0.931 grams. This iron bolt partially rusted. And that rust on it is going to increase the mass of this bolt, but at the same time, some of this iron is going to be removed. So what you have to do is say, wait a second, my original iron bolt was 5.21 grams, and I found that 0.651 grams of it went into making iron oxide. So my iron bolt decreased in mass. The iron is changed into iron oxide. So all we've got left is 4.56 grams of pure iron. And in addition to that, we now have rust that's being made, the Fe2O3. And a simple addition, and you get your rusty bolt. You've got the iron and you've got the rust, and they come together. And it makes sense. You expect 1/8 of it becomes heavier because it gains oxygen. Now, there's a faster way of doing this. If you're a really clever student, you could figure out, oh, it's just adding a little bit of oxygen. All I've got to figure out is how much oxygen is being used, and that would end up helping you find the total mass. Like I say, there's a shortcut, and if you're sharp enough to use it, it would certainly be given 100% credit by a grader. In fact, they might be impressed. But at the same time, you should understand the stoichiometry of this problem. I mean, this is beautiful. We've got a reaction that's difficult to balance. We've got to change grams into moles. We've got to use stoichiometry. We've got to change moles into grams. And then we've got to be careful enough to see that some of this iron was removed and then changed into iron, and we've got this total answer at the end. Well, good luck doing the problem, because you've got a different amount of mass in the problem that I've given you, and see if you can get it on the first try. Stoichiometry, AP chemistry, very good. Oh, by the way, rust is just amazing. It's a chemical that's been used for tens of thousands of years. Even Neanderthals used rust. In fact, let me pull up a page here. This is a cave where about 40,000 years ago, somebody took a piece of hematite, basically rusted iron oxide, and made this drawing on a cave wall. So, find a cave somewhere, grab a rusty bolt, and do this problem on a cave wall. And then maybe 40,000 years from now, somebody will be able to see your AP chemistry problem solved. All right. AP Chemistry, good luck with that problem.